Now let's consider the following problem. Considering configuration below, what is the B field at point P, right? So we have basically two semicircles, right? This is basically R1, this is R2, right? Semicircles are drawn as best as they can, right? And a current flowing around it, right? So this is another case of the law of Biot-Savart. So I'm going to use the law of Biot-Savart. So dB is equal to mu 0 over 4 pi I dl cross r hat over r squared. Okay, and so to get the B field, we're going to basically do an integral over B. So B is equal to integral of dB. This is always true. Mu 0 over 4 pi. I know I is a constant, so I can just bring out dl cross r hat over r squared. Okay, so there are two segments here, two semicircles. So I'll label this segment 1 and label it segment 2. And there are two straight segments, basically number 3 and number 4. Okay. Now, if you looked at the previous one, you know that in that case, segments along here and here will have basically DL will be parallel or anti-parallel to R, and so those segments will be 0, right? But just basically more broadly, we can write like this. Okay, so the B field is going to be equal to integral along segment 1 of mu 0 over 4 pi I dl cross r hat over r squared, plus integral of segment 2 over semicircle 2 mu 0 over 4 pi I dl cross r hat over r squared, plus basically segment 3 plus segment 4, right? But if you look at the previous video, you know these are equal to 0. Okay, so we're just left with two semicircles, all right? So let's go ahead and do them. Now, remember, R points from basically the source where you're looking at. So let's say this is one source, this is DL, pointing back to the direction which you're looking at. And in this case is at 90 degrees because it's a semicircle, right? Same thing here, right? So this is pointing in this direction. It points back this way. That's R in this case, R in this case, pointing this way. This is DL, okay? Again, 90 degrees. Now, let's just check the directions, or let's just check the direction of the B field in those cases. So, the fact that 90 degrees means that the magnitude of this thing is just going to be DL. Magnitude of this thing is going to be DL. And then basically let's get direction. So you the right-hand rule again. I'm going to do this side first. Basically, this is DL, thumbs along DL, first vector. Fingers are along R, second vector here. Okay, and so it points back into the page. So that's basically along segment 1. And if you do the same thing along segment 2, you also find basically it also points into the page. So this is 1 and 2 points into the page, right? So if z-axis is out of page, then I can rewrite these things as z-axis point into the page, right? So this is going to be integral along segment 1, mu 0 over 4 pi I dl over r squared, now look at the direction, minus z hat, plus integral of segment 2, mu 0 over 4 pi I dl over r squared, and this again in the minus z hat direction, right? And now the only thing I need to do now is basically do these two integrals, right? So fortunately for me, because of the semicircles, R is in this case going to be R2 for segment 1, unfortunately, and 2 and R1 for segment 2, right? I should have labeled it a little better. Oh well. Okay, so let's go ahead and do this thing. This is going to be mu 0 over 4 pi times I, and then this is just going to be integral of dl over r1 squared in the minus z hat direction, segment 1, plus basically mu 0 over 4 pi I integral of dl over r2 squared in the minus z hat direction. Again, these are integrals over two semicircles, so this integral up here will be pi r1, this integral here will be pi r2, right? And so we're done. So this is going to be equal to mu 0 over 4, okay, I, and now this is just going to be 1 over r1 plus 1 over r2 in the minus z hat direction. And then we're done.